Hello, it's Frederick. In this video, I'll briefly introduce what is the knowledge graph. This video will be structured in the following way. First, I will give a high-level overview of knowledge graph. Then I'll talk about some basic concepts in knowledge graph, entities and relations. Finally, I will introduce the motivation and applications of knowledge graph and do a conclusion. So, first, what is knowledge graph? To get started, let's look at a specific case of knowledge graph, the social network. So in social network, each of the node is a user, and there's only one type of node in this graph, that is the user. And similarly for the edges, there's only one type of relations represented by the edges, that is the relation friend of. And of course, we can make this more generalized to real world. So on the right hand side is a typical knowledge graph. So it includes the people, Alice and Bob, Leonardo da Vinci, and the famous painting Mona Lisa, and days and concepts and so on and so forth. And the linkage or edges represents the relation of friend of, interested in, born on, and so on and so forth. There's no semantic meaning on them. And it's worthwhile to mention that a typical knowledge graph will be of larger scale than this toy example. So now let's dig into the concepts of knowledge graph, entities and relations. Take a look at the sentence, Bob is interested in Mona Lisa. In this example, Bob and Mona Lisa are entities, and interested in is called the relation. And for convenient representation purpose, we put the sentence into a triplet as following. Bob is the head entity, be interested in is called the middle relation, and Mona Lisa is the tail entity. Putting all of the previous mentioned elements together, we get a knowledge graph like this. And knowledge graph is typically stored as the triplet mentioned here, and for users, it's very convenient to visualize knowledge graph like this graphical way. And now let's talk about the motivations of knowledge graph. So, computers does not understand human language. For example, if we tell the computer that Bob is the friend of Alice and ask the computer who is Bob's friend, there's no way the computers can give us an answer. To solve this problem, we come up with knowledge graph. So it's a widely accepted fact that knowledge form of data is generally easier to be represented and understood by computers. We will not discuss the exact reason because it's well beyond the scope of this video. So next, let us review some the spirit behind applications of knowledge graph. So first is prediction as listed as shown as the left hand side. In this example, we have Tom, Bob. They are interested in Mona Lisa, and Tom and Bob are friends of Alice, but not friends with Mary and Anna. We ask the question, who are most likely to be interested in Mona Lisa next? The answer very heuristically is, of course, Alice. And another spirit is completion, graph completion. So we have a missing part as a square, and we want to find out what is the missing part. What we know for the missing part is that it was created by Da Vinci, and Bob is interested in it. And combining with all we know from larger knowledge graph, we will most likely to be able to find out this missing term. So following this spirit, we have some real world application. Recommendation system like YouTube and Amazon. Knowledge bases constructions such as Wikipedia and search engine improvement used in Google, Yahoo, Yandex, and so forth. So finally, conclusion. First, knowledge graph is generalized structured representations of objective facts. No semantic limitations are set on nodes and edges. And second, in knowledge graph, knowledge is represented as a triplet form of head entity, relation, and tail entity. Finally, knowledge graph is machine understandable, and it has many important real-world applications following the spirit of prediction and completion. That's so much for it. Thanks for listening.